In this video, we're going to look at the issues, the environmental issues related to road runoff. So we're looking at a traditional drainage system here. So the rain falls on the road, the water on the surface flows off the road. In an urban system, it flows into a piped system which directs it straight into a stormwater system, and then the stormwater system discharges it into the local water system as fast as possible. Um, that's the logic behind a traditional drainage system, is to get the stormwater, the rainwater, out of the community as fast as possible and into a local receiving water. Now that causes some problems. So here's the natural water system. So this is a natural water cycle. We looked at this in the hydrological cycle in the previous video. So, the rain comes down, it falls on the ground. There's lots and lots of infiltration. So water, the rainwater flows into the groundwater. And so you get a high groundwater flow going in and recharging streams all the time. You get the runoff, but the runoff is delayed by the vegetation. It's not flowing as fast over the land as it would in a pipe system. And a pipe system would drop there and the pipe would take it straight out. So a pipe system is designed to transfer water from one place to another as quickly as possible. And obviously, as it's traveling along, there's evapotranspiration. The water's evaporating off the surface and it's providing more water coming up into the clouds to form more condensation. So this system works quite well. The water, as it's flowing over the land, is also being treated. Any contaminants that might be picked up along the way get filtered out by the grass and the vegetation as it flows through. So when it reaches the stream, either from overland runoff or from groundwater flow, it's relatively clean. And it's buffered as well. It's not too much of a flow. Now, once we put in an urban system where the traditional system with pipes and stuff, there's much less infiltration because we've got all these impermeable surfaces, roofs and roads. They're designed not to let water in, and they're drained by draining them into a stormwater system and into pipes and then directly into the stream. So there's much less infiltration going on. So the groundwater flow drops off. There's more runoff, but that runoff is via the pipes and it's directed into a different place. So there's less flow going into a river except when it's raining and from that pipe. So that pipe is going to have a much higher flow going into it because all of the water that's been dropped in the ground is immediately being transferred into the stream. Now that has some significant problems. So this is a hydrograph. So this is the flow rate with time. So here's what it would be pre-development. So the rainstorm starts, the river sees the flow sort of building. As the rainstorm builds, then the rainstorm stops, and then a little bit more water sort of flows through. Now that would have actually a longer lead because more water is just making its way slowly across the ground. But when you've got post-development, so you've got increased flows, more flows coming through the pipe system because there's less flow infiltrating into the ground. So there's a much higher peak, and it peaks much higher, much faster, and then it drops away. So what's happening is the stream that used to see this sort of flow is now seeing this flow. It's much higher flow. When the stream is flowing faster, it's more likely to start eroding its banks. When it's eroding its banks, it's bringing earth and stuff into the system. So the quantity of water, the amount of water that's entering the system, is much higher. It's coming in through as a peak rather than a prolonged flow, which is what happens with the normal systems. In addition to that, we've all got all sorts of contaminants which are on the ground, on roads and things like that. It's oil and gasoline off trucks, trash that sort of falls off, dog doos and stuff like that, nutrients, gasoline, spillages, people tipping paint down on the road, fertilizer and stuff off the trees that are beside the road. sediment, if there's no trucks are dropping dirt on the road. Also, the tires of cars leave heavy metals on the road as well. So all that washes into um, the stormwater system, and then in a traditional system, it goes straight into the river, which then goes into the water body. So you can see that there's lots of sources of contamination, and there's nothing between the contamination and the water body. So that is a major problem. So we have the quantity of runoff, which is causing a problem, and now we have the quality. We have polluted water going into the water bodies. So those are the two main environmental problems. And that's sort of not acceptable. And basically, that's us moving away from a natural system. So more and more recently, we've started to get into this thing called water sensitive design, also known as low impact design. And what it aims to do is it aims to deal with the water, the runoff from roads, uh, in a way that's more in keeping with the way nature deals with it. So you can see that you've got the runoff coming off the road here, and instead of going straight into a gutter and into a stormwater system, it goes into a soil area where it infiltrates down. It's given the opportunity to infiltrate down into the ground to become part of groundwater. That has two advantages. First of all, it's not going straight into the river and causing extra flows. And secondly, as it moves down through the soil, it's being treated. So we're going to be looking at this more in a later video, but what I want you to take away from this video is there are actually two different approaches. There's the traditional approach, which we've been using for the last 100 years or so, and then there's the natural approach, which is becoming more popular in response to the pollution and sustainability issues that we have in our community. People are more aware of it. They're more concerned about trying to keep our water bodies clean, and this is a really good response to it. We'll be talking about this more in a later video.